Well, now that we know what the average rate of change is, we're going to look at what the instantaneous rate of change is. And instead of the slope of a secant, we're going to be looking at the slope of a tangent line. So, what is an instantaneous rate of change? How is it different from the average rate of change? So we know that the average rate of change is between 2 points, right? Because that's what a secant is. It intersects 2 or more points, and we're finding the slope between those two. But an instantaneous rate of change, we're finding what the slope is of this tangent line at a particular moment. So like, instead of how many donuts are made between, or what's the average rate of donuts made per minute between, let's say, like, 2 minutes and 5 minutes, we're saying what is the rate of donuts made per minute at exactly 2.5 minutes? What is the rate at exactly that time? And in order to do that, we do a tangent line. And a tangent line is just, instead of intersecting 2 or more points, it only intersects once. So let me just put this into words to do a bit more of a visual example. So let's say that this is a time versus donuts made graph. So they start off really strong, whoever's making the donuts. Then they forget the ingredients, they mess up, and then they totally go down a bit. And then it's slow, and then they basically go slow the rest of the day. So something like that. So to find, let's say that I want to find what it is, the slope is at exactly this, or well, not the slope, what the rate of change is at exactly this moment. In order to do that, I draw a tangent line, which means that it will only intersect once at that one point right there. So when I find the slope of this line, that is what the instantaneous rate of change is. It's what the rate of change is at that particular moment in time. So how do we actually do this? Let's take a look. So we're given this, and this is f of x equals x cubed plus 2x squared minus x plus 1. So let's say that the question says to find out what the average rate of change is, the instantaneous rate of change is, my bad, when x equals -1. And that's all it tells us. That's all it's going to tell us. So how do we find that out? Well, I did like a little graph. I have no idea what this function looks like, but let's pretend that this is what it is. It's saying what's the rate of change at that exact moment right there. So we got to draw a line that looks something like that. So first off, what we're going to do, we're going to figure out what the y value is at that point right there. So how do we do that? We're gonna plug in our x as -1 to see what it spits out as our y value. So let's do that. So f of -1, which is basically just y, equals, and then we're going to do -1, substituting all of the x's we see with -1, squared minus -1 plus 1. So f of -1 is going to be -1 plus 2, then plus 1, plus 1. So f of -1 is really going to be 4. It's going to be 4. Because -1 plus 2, that's 1. 1 plus 1 is 2 plus 1. That's going to be 3, not 4. Let me change that really quick. There we go. So f of -1 is 3. When x is, aka when x is -1, the y value is going to be 3. Definitely not 4. So what do we do next? So we've got 1 point, but we can't find a slope. So in order to find the slope, if you wanted to be super duper accurate, then you could use calculus, but I don't know how to do that. I haven't taken calculus yet. So the only thing that we learn, we're going to get, technically our answer is not exactly precise. It's the best that we can do at this moment before taking calculus. But what we want to do, and then if you look at the graph on the left, we're basically finding a point so like minusculely to the right of that point. So we're adding literally 0.001 onto our x value to see what the next y value will be of the function, and then we're going to take the slope of that. And it's technically, it isn't the slope of a tangent. It's going to be, if you zoom in really, really, really close, it's actually going to be the slope of a secant, except it's basically the slope of a tangent that it's so tiny that we're just calling it the slope of a tangent. So, anyways, getting into it. So, what is -1 plus 0.001? Well, that will be f of negative, let me do the calculation, plus 0.001. I don't want to mess up like I did with that 4. So that will be, yeah, I thought so, 0.999. So what is the y value when all of our x's are negative 0.999 cubed plus 2 negative 0.999 squared minus negative 0.999 plus 1. So we're going to do that. We're going to type that into our calculator. 999, and that's to the power of 3, plus, and I'm just doing this on a calculator by myself right now, 2 times negative 0.999, and that's squared, minus negative 0.999, and then plus 1. So if you type that into your calculator and you did that correctly, then it should give you a y value of 2.998 approximately. We're not going to keep every decimal in because that would be insane. So that's our hold on, let me write out both points, and then we can list our x and y variables. So we got this one, and then we've also got hold on, let me change colors. And then we've got when x is negative 0.999, y is 2.998. So this will be our, actually let me change color once more. This is going to be our x1, this will be our y1, this will be our x2, this will be our y2, and now it's simply just finding the slope. So let's do that. The instantaneous rate of change equals y2 minus y1 over x2 minus x1, or the change in y over the change in x, same thing, or even rise over run. So we've got 2.998 minus 3 divided by, and that's going to be x2 negative 0.999 minus negative 1. So that's going to be equal to, and then let me type that in, 2.998 minus 3. That's going to be equal to negative 0.002 over, then we're going to do negative 0.999 plus 1, because a negative and a negative, and that is 0.001. So that's going to be equal to 0.00, it should be negative 2, I'm just going to double check though, divided by 0.001. Yeah, that's going to be negative 2. So the instantaneous rate of change for this one will be negative 2. So we can finish it off once and for all with a therefore statement. Therefore, the instantaneous rate of change, or IROC for short, of f of x when, or not when, should be at the instantaneous, basically the instantaneous rate of change of the function f of x at the exact point when x is negative 1 is negative 2, and then it would be whatever units you have, but since we don't have any units for this one, we're just going to leave it as negative 2.